Welcome everyone, and thanks so much for joining us today. Today we're going to go through a quick anatomy of the DDoS attack that occurred on AWS on October 22nd, 2019. My name is Craig Lowell, Product Marketing Manager here at Catchpoint, and I'm joined today by Nith Mehta, our VP of Technical Services. So today we're going to go through an overview of the outage and what happened, try to get a grasp of how long and how widespread the effect was, and then we're going to go through some of the best practices for detecting DDoS attacks and how you can take back control of your digital services. So I'm going to throw things over to Nith.
Thanks, Greg. Hi, everyone. Thanks for joining. So yes, so this problem we started seeing a lot of customers getting DNS failures and DNS failure-related alerts. And we first started noticing problems at about 5:20 a.m. Pacific time. We saw alerts originating from data collected from San Francisco and the West Coast nodes, as you could see on the screenshot there. While we did see failures across North America, the West Coast was the one that was mostly badly impacted, like we see in the screenshot there on the right side, about 115 failures in San Francisco. We do see a small percentage of failures from other locations, but we started seeing DNS failures, poor DNS resolution time for hundreds of websites of our customers and other internet websites which leverage AWS platform. So what did we see, right? So, well, at the end of the day, we've been talking about all these different incidents that happened over this summer, starting with Verizon, Cloudflare, and a lot of other similar incidents. And every single time it boils down to how soon are you able to detect this problem. And even in this scenario, when we started detecting this problem from different locations, some of our customers reached out to check why they were seeing failures, and we noticed failures in San Francisco and a few other locations, but most related to DNS, timeouts and no response or connection failures to their name servers and so on. This was as early as 5 a.m., so obviously it woke up a lot of people from sleep. And seeing these intermittent failures made customers suspect if it was something to do with the internet. But what we saw was a failure specific to a certain set of hosts, and we narrowed it down to a problem with AWS, and our customers reached out to AWS support to check if they were aware of any problems. And what was interesting was they were not aware, nor were they able to replicate this problem. And as you could see in the screenshot, it was about 5:20 a.m. Pacific time. And about 5 hours later, AWS did confirm that they'd had a DDoS attack, and they saw some DNS-related problems, and they updated their status page. What you see there on the right side of the screenshot of the page is a screenshot from their status page where they started detecting problems from 10:30 a.m., but we did see websites and a lot of companies impacted almost 5 hours prior to AWS updating their status page. Right? So, and again, it's a reminder of why it is so important to monitor all these endpoints from different locations, because often your vendors might even be blindfolded of these problems that is impacting your end users. So how soon you detect this helps you reach out to the relevant to the respective vendors so you can notify them about this problem and get it resolved. So mean time to detecting a problem is really key, because that determines how soon you're able to resolve or get the right people on the call to get these problems resolved. So here is an example, and this is a very interesting example. In fact, this is a website called amplitude.com where they are leveraging a lot of AWS services. So this is their homepage, and what you see here is www.amplitude.com. And as the page loads, you see several other hosts. Now, the entire site is on AWS, but www.amplitude.com did not have any problem, whereas they had some child hosts or other requests on the page which were coming from S3-US West Amazon AWS.com that had high DNS problems. So it's an interesting thing, right? So we did see AWS DNS having a problem, but the point to note here was it was not whole of AWS. It was a specific authoritative name servers of AWS related to S3. We'll talk about it more in detail, but this is an interesting use case and the need why for a monitoring strategy that goes beyond just looking at checking if your primary endpoints are reachable and available. So, and the reason why I said that is continuing what we discussed in the previous slide about amplitude.com, the screenshot on the left side is a Catchpoint's a DNS experience test result snapshot, which is basically more like what you would do from your console, like a dig plus trace, where we see on the left side, when you try to resolve www.amplitude.com, you get the name servers, which are different from what you get for your child host, which is the one on the right side, and the name servers U1, U2, R1, and R2 are having a problem or had a problem. In fact, R1 is still having a problem where we see failures even today as we record this webinar. So to reiterate, not whole of AWS had a problem, but S3 and a certain authoritative name servers related to S3 were the ones that were impacted. All right, so what was the impact, right? And how did we determine this was a DDoS from an end user point of view, right? So what we see here on your screenshot is Catchpoint's network insights, a hop-by-hop visualization, which helps you to understand, basically visualize the trace route, how the packet traverses through, and look at where the problem is. So as you can see on the screenshot, all the packet loss is noticed on the extreme right of the last hop of each of these the hop-by-hop lines that you see there for each city. And that indicated that there was a problem at the endpoint itself where we see packets being dropped, right? Typically, this happens when there's too much load, which is genuine traffic, or they're under a DDoS. And we were able to confirm this if it was a DDoS, because typically this is when companies redirect their traffic to the scrubbing centers, like in this case. The trace route helped us to narrow down that, yes, they were in fact rerouting their traffic to, in this case, looks like the scrubbing centers, which they're probably leveraging the Neustar's security protection service. So even all the genuine traffic along with all the DDoS traffic was sent to a Neustar, where while this helps in protecting them from DDoS, but all the genuine traffic also has to go through this, which means the users are going to see slow DNS resolution time, poor application experience, and so on. Right, so good thing and the bad thing here is that the sooner you detect, it's important. So in this case, it was a vendor, so all the customers were able to reach out to AWS. It did take some time. But eventually AWS started resolving this. When the failures reduced, we saw some latencies. So it's really important to try and detect these problems as soon as possible. But there are also some best practices that you can consider in order to ensure that you protect yourself from these kind of attacks, because this happens to large enterprises almost every other day, and cloud and other major service providers are not an exemption from as such. And so it's so important that you consider some of these best practices to ensure that you're able to scale, have the capacity to handle any additional genuine traffic or, in fact, malicious traffic such as this. And it's so important that we also focus on approaches to decoupling your infrastructure in order to ensure the impact that these kind of attacks can have. And the third, and probably the most important one in a scenario like this, like the amplitude scenario that we spoke about, where you alert for anomalies, right? If you're looking at application performance alone, and with Anycast and other kind of DNS set up in place, you probably might not see a lot of DNS failures, because if one fails, you might get rerouted to the other and so on. So it's really important that you also alert for those anomalies, and also consider your delivery chain, which is so important, because typically companies look at monitoring the overall application performance and forget about that critical delivery chain components like your DNS, CDN, if you're using any cloud-based load balancing solution and so on. So it's so important that you alert for anomalies and also take into consideration your digital delivery chain, because they can make a lot of difference in scenarios like this. And finally, ensure that you have redundancy, not just in case of DNS in this case, in the previous example a couple of months ago when a CDN went down, a multi-CDN and other kinds of strategies are so important, especially with Black Friday around the corner.
All right, thanks so much, Nith. So as Nith was saying, the real key to mitigating the impact of outages like these, either from DDoS attacks or any other sort of outage, is through shortening the amount of time it takes to complete these 5 critical steps of the resolution process. So obviously the sooner that you can detect the incident, you can identify the root cause and then escalate to the proper channels, which in this case was AWS, the sooner you can actually get those services back online. And then obviously if you do have redundancies in place for your DNS or your CDN or any other infrastructure within your IT architecture, you can then switch to those once you understand where the problem is. Okay, so how do we actually accomplish that? And the key is really through prioritizing the end user. So in the old days when all of our applications and infrastructure and services were in our control, it was really easy to detect problems and identify the root cause. And as you see on the left, that's where folks' priorities used to lie. It used to be all about monitoring the infrastructure, the network, the application, and then whatever was left over was used for end user experience. But because all of our architecture components are, or at least most of them, are now out of our control, it's really critical to monitor from the end user first so that you can be alerted to incidents like this. And that's exactly why we saw Catchpoint customers be able to detect problem several hours before AWS does, because they were actually monitoring from that end user perspective. So they knew there was a problem, and then from there they were able to drill down into the specific components. So by taking that wide angle approach, you can ensure that you're really catching everything, and then from there you can identify where the problem is and get that more granular data, which in this case was through DNS monitoring. So as far as the network components are concerned, Catchpoint has a product that is called Network Insights, which is comprised of 4 specific capabilities that you see here. So one is traceroute monitoring and visualizations, which we saw earlier. We also provide BGP monitoring, enterprise and endpoint monitoring, where you can actually monitor SaaS applications and business critical in-house applications that your employees use. And then of course you have DNS. So when it comes to DNS monitoring, Catchpoint offers different types of DNS-specific tests. First, we have direct name server tests, which directly query the name servers, and these just provide availability data and ensure that the responses delivered by those name servers are accurate. But then we also have DNS experience tests, which run recursive queries to resolve DNS, just like the actual recursive DNS servers do. So by doing this, you can actually measure latency, performance, and availability of all the various DNS servers in the pathway, which of course allows you to protect against things like DDoS, DNS hijacks, and cache poisoning. So when we talk about testing from that end user perspective, one of the biggest keys that enables you to do that is by testing from where those end users are actually located. So not only the geographic locations, but also the different types of networks that they're on. So whether it's backbone and broadband, the last mile networks, the wireless networks, or the cloud networks that users are transversing in order to get to your applications and services, you want to be able to test from those perspectives in order to understand what the end user is really experiencing. So this is a really important point, because a lot of other monitoring solutions out there, their test locations are either entirely cloud-based, or maybe they have a few backbone locations, or 1 or 2 of these different types. But Catchpoint actually provides all 4 different types of testing locations, which allows you to get a complete 360 view of your end user experience and really understand what those end users are experiencing and on what networks and geographies they're experiencing those issues in. So that wraps it up. I want to thank you so much for joining us today. Thank you to Nith for providing that insight. And for more information on this incident, as well as how you can use digital experience monitoring to better understand your end user's experience, please go to catchpoint.com. Thanks so much and have a great day.